A very good morning, good afternoon, good evening, or good night, depending from where you are in the world. Welcome to this next session. My name is Lars van Dijk. I have the honor of being your moderator today. I am streaming from Singapore, where it's a nice 7 p.m. at the moment. We've just entered darkness here. So from wherever you are, I hope you will be enjoying the session. It's my honor to introduce to you today Bill Keeter. He is the owner of BK Reliability, and he will be talking about a subject that is close to our heart as well, about condition monitoring. And the topic is condition monitoring. It's not about the tools. He will explain why it's more than just the tools. He will be explaining how you can take away common roadblocks, factors that will become roadblocks on your road to a successful condition monitoring practice and setup. So I can't wait to hear what he has to say. So without further ado, I'm going to bring online Mr. Bill Keeter and his presentation. Enjoy the session, and I'll see you later. Please feel free to add your questions to the chat, and we will discuss them later with Mr. Bill Keeter. Thank you. Enjoy.
Hi, I'm Bill Keeter. Welcome to It's Not About the Tools. Has your organization invested lots of time and money in predictive maintenance tools? Are you still not getting the results you want from your program? In this presentation, I will talk about some of the available tools, the equipment life curve, the P2F interval, how early during the P2F interval some of the tools can detect potential failures, the organizational implications of the P2F interval, and lastly, how to become more successful with your condition monitoring program. There are lots of condition monitoring tools available to help organizations understand the health of their equipment. Vibration analysis is probably the most widely used. It can find a variety of mechanical and electrical faults if they create an unbalanced force that causes vibration. Ultrasound detection is another popular tool that can detect various faults using airborne and structure-borne ultrasound. For example, analysts can use ultrasound to detect compressed air leaks, bearing defects, control valve performance issues, and electrical faults. In addition, it is beneficial for properly lubricating rolling element bearings. Thermographic imaging is probably one of the most underused condition monitoring tools out there. Many organizations use it only for monitoring electrical equipment. However, analysts can use it for detecting electrical faults, electrical motor issues, bearing defects, misaligned belt drives, over-tightened belt drives, and many more. One of the most exciting developments in condition monitoring is motion amplification. It helps improve communication between the analysts and the end users of the equipment. That makes it easier to get cooperation for fixing the faults. The team that invented reliability-centered maintenance in the 1970s decided they needed a working definition for failure. So they developed 3 definitions to guide their work. A failure is the presence of an unacceptable condition. The elegance of that definition is that the organization determines what an unacceptable condition is. A potential failure is an identifiable physical condition which indicates a functional failure is imminent. Imminence is in the eye of the beholder. Functional failure can occur within a few seconds or take months, depending on the fault detected. The team clearly defined functional failure as the inability to meet a specified performance standard. The P2F interval is just the time between when a potential failure arises in the item and functional failure occurs. The characteristics of the P2F interval determine whether an item requires continuous or route-based monitoring. Items with short or erratic P2F intervals need continuous monitoring so organizations can shut down systems without incurring additional losses. You can use route-based monitoring for items with long, stable P2F intervals. You can manage those items to minimize the business impact of their functional failures. The organization must be able to plan, schedule, and execute a corrective maintenance job within the P2F interval if it is going to have a successful condition monitoring program. Therefore, you must have a robust planning and scheduling process. Detecting potential failures early gives you more time to plan, schedule, and execute a repair. Ultrasound detects potential failures very early. It doesn't give you much information about root cause most times, but it does give you more warning time. You can see from the I to P to F curve that using human senses alone doesn't give you much time to react. One of the most frequent mistakes I have seen is asking when the item will fail. The analyst may have some idea, but he or she will be unable to give you an exact time. The best answer an analyst can give is, it will last until it fails. We like to call working this way optimizing your run-to-failure program. You must manage to the P of the P2F interval to be very successful with condition monitoring. I'm not saying you should interrupt the production schedule to complete corrective maintenance, but you should immediately plan the job. There are 3 possible outcomes after you plan and kit the job. The item will fail before you can get the job done. Having the job planned and kitted means the failure's business impact will be less than it would have been. There will be an unscheduled opportunity to complete the job. Planning and kitting the job means you will be able to take advantage of the opportunity. The job will be integrated into the regular maintenance schedule for the item. That gives you the maximum benefit. Managing to the P maximizes the business benefit of your condition monitoring program. To summarize requirements for an effective program, put together the job plan. Make sure the job packet includes lockout, tagout plans, special tool requirements, and installation and repair standards. Get the parts together, kit them, and stage them if you can. Put the job on the hot list so you can do it if the opportunity arises. Make sure you are ready to do the job if the item fails before you can replace or repair it. Use precision maintenance methods during the installation or repair. Success requires cooperation and teamwork. The maintenance team needs to make repairs and installations using precision maintenance methods to ensure an excellent start to the I to P portion of the DIPF curve. The operations team needs to ensure equipment is started up and operated to maximize reliability. Operations and maintenance need to work together to perform routine maintenance activities such as cleaning, lubricating, and adjusting equipment to maintain its effectiveness. Everyone needs to work together to understand the current health of the equipment using technology and PM inspections to help minimize system downtime. Thank you for attending this brief presentation. Please contact me with any questions you may have or if you need help with your maintenance and reliability program.
Okay, that was great. And thanks to Bill for organizing this presentation. So let's bring Bill into the screen here as well and see if we can answer some questions with him. Good morning again to you.
Thank you, Lars. Hello, everybody.
That was a great presentation. We really enjoyed that.
Appreciate it.
At the moment, I don't see any question. There's a compliment, though, that the presentation looks nice. Good animated, well animated. So that's a good compliment to you. That's from Ahmed Mazar Bashir, who comes from in Canada. So he's giving you a compliment on the presentation. He's also asking now, are your services available in Canada?
Yes, they are.
Okay, that's great to hear.
Been there
Without,
multiple times.
yeah, okay, that's good. So there are no other questions at the moment. If you don't mind, I do have a question that popped up in my mind.
Sure,
As
Lars.
Thanks. As you know, I work for Fluidtech, and we specialize in loop oil optimization and oil life extension. And a
Right.
big part of that is also condition monitoring. So I would like to hear your thoughts on, to give a bit of background. We see that OEMs are also opening up more and more to the aspect of the loop oil itself being an asset, and
Right.
when you maintain it well, it has a lot of benefits operationally and financially and so on.
Right.
We see really a big shift, a paradigm shift, if you will, in this industry. So I'm wondering, what are your thoughts on this in general, and how would you integrate loop oil condition monitoring with mechanical condition monitoring, for example?
Oh, it's extremely important for your rotating equipment. I mean, uh, when I was maintenance manager, this was 20 years ago, we were using it extensively in our plant, especially on the very important equipment.
Hmm.
I think there at one time there was a misconception that doing lube analysis was only for your larger sumps to help you optimize oil change intervals and all that. But it's such a powerful tool for understanding the condition of the equipment, not just
Hmm.
the oil.
Hmm.
And you just have to make sure you're using all the right tests. As you know, you need to be
Hmm.
using the wear metals test, the particles test, the contaminants test, water tests, and make sure you're using the right vendor to make it happen and happen well.
Yeah.
And it can give you a good long range warning before you actually suffer a failure.
Hmm. Hmm. Yeah.
So, an important part of any condition monitoring program.
Great, great. Thanks. Yeah, we always like to compare it with running a blood test when you go to a doctor.
Yeah. In
Yeah.
fact, that's, believe it or not, when I was a maintenance manager, I actually wrote a paper that compared lubricants to your body's blood. So,
Wow.
it's the stuff that keeps the equipment alive.
Yeah. Yeah.
And I've seen evidence that as much as 80% of bearing rotating element failures are related to improper lubrication practices.
Wow.
So lube practice and lube analysis are very important.
What is the most common mistake in bearing lubrication, or not? Let's not call it mistake, but
Yeah. One of
suboptimal
the
practice that you encounter.
yeah, the biggest suboptimal practice is putting too much lubricant in the bearings.
Yeah.
You
That makes
know,
sense.
the amount of lubricant that goes into a bearing depends on the rotational speed, the conditions you're working under, all sorts of things, and those OEM original recommendations for a lubrication interval are nice
Hmm.
and a good starting point, but you need somebody there to help understand. Well, we're out in the middle of the desert in Saudi Arabia.
Yeah.
We're going to have to do something a little bit different, or we're near the Arctic Circle and we're going to have to do something different there to make sure that the lubrication's done well and done right.
Yeah.
Uh, One of the best tools available now, of course, is the ultrasound assisted lubrication, so
Okay.
that you can get the exact right amount of lubricant in the bearings. You have to be careful with it. You don't want to try to apply it somewhere where you don't want to apply lubricant while that piece of equipment's operating.
I see.
For stuff that can be running and rotating, it's a very, very powerful tool for getting lubrication right.
Thanks for that. That's really interesting. I have a question coming in now.
Okay.
Which is the best and most error-proof particle counter you would recommend for loop oils of turbo machinery?
You'll have to answer that one, Lars. I don't have specific equipment knowledge.
Yeah, that's actually, I would also know. I'm not from the lab myself, so I would also
Yeah.
not. But we'll try to get.
Samantha, I'm sorry that we can't answer your question.
Yeah, unfortunately. Yeah.
Maybe
maybe look
someone
at
in the
some.
audience has a suggestion that they
Yeah,
could type into the stream.
that's a good point. If someone has a suggestion for Samant, then please go ahead and type it in the chat. If not, we will try to get back to you later. I'll take note of your question. Light, laser, or mesh, at least. That also depends on the type of contamination.
I would think so.
So, yeah, a laser is typically better for certain particles of an inorganic nature, but the mesh gives you also a good indication of the size and usually more
Yep.
yeah, detail. So it depends really on the type of contamination, unfortunately. But I'll try to get back to you, Samantha, with some more details on this question. Thanks for that. So coming back to condition monitoring and in the training program, how do you implement this at a company? You had this very nice slide in the end where everybody's rowing in the boat together. So when it comes to training, how do you implement the loop oil condition monitoring in the practice? Is it a matter of educating people?
Yes. There's multiple things you'll need to do to make sure you get lubrication and lube oil analysis right.
Mm-hmm.
The first thing from a lubrication standpoint is you're going to want to train the people who are going to do the lubrication on exactly how to do it.
Mm-hmm.
So there are some good programs out there for training machinery lubrication technicians,
Yeah.
and helps them understand, how the grease gun works, what kind of grease gun to use for greased bearings, the the characteristics of the lubrication oils and all of that kind of stuff, so
Mm-hmm.
that they understand. And also from a lube sampling standpoint, I mean, the biggest mistake that most people make with lube oil sampling or their lubrication analysis programs is that they get poor samples
Mm-hmm.
because they don't train the people who are taking the samples how to take them exactly right.
Yeah.
So they've got sample points in the wrong place. They aren't very careful about not contaminating the sample by the process of taking the sample.
Yeah.
And if you've got bad samples, everything's out the window then, because that
Mm.
sample's not going to tell you anything.
Yeah.
So you need training for that. You need training for the person who's going to manage the program, because there are some trendings and things like that you need to keep track of. And you
Mm-hmm.
need to go out and understand exactly what metals of construction are in whatever it is you're testing, so
Mm-hmm.
that when those wear metals do show up in the sample, you've got some idea of what part of the gearbox might be failing.
Yeah. Exactly. Great stuff. So, if you would dare to indulge us, would you dare to guess the amount of dollars? Maybe you want to segment this into markets or industries or however you want to, but would you take a wild guess at how much money is left on the table at the moment by companies um, without
Oh,
that do
wow.
suboptimal condition monitoring?
Or just condition monitoring in general, or
Yeah,
lube oil sampling? Okay,
no, just
so
condition monitoring in general. Yeah.
I've done a lot of analysis, RCM analysis, using a powerful tool that lets you understand what the payback is for what you're doing.
Mm-hmm.
And typically, the payback for doing condition monitoring on the failure modes is somewhere between 7 and 10 to 1.
Oh wow, so
Uh,
wonderful.
in those places where they don't have condition monitoring, or
Yeah,
those items they're not doing condition monitoring on, it's a no-brainer investment.
yeah,
Uh, and I know it. The problem is, a lot of times it looks like, voodoo, because the people don't understand exactly what the analyst sees. But
mm-hmm.
super good investment. You can't
Yeah,
go wrong. You almost can't oversample,
yeah,
right?
yeah. Yeah, data is key, I would
Yep.
say.
Good
Yeah,
data helps, but the payback is really good.
yeah, exactly. What it's maybe a general question, but what would you say is the biggest challenge that you face for convincing people to adopt a good condition monitoring program?
The biggest challenge is their lack of education about the benefits.
Okay.
and how big the benefit will be.
Yeah.
And now I did work with one company 20 years ago almost that had hired somebody to come in and set up their vibration analysis program.
Hmm.
And instead of using a criticality process to set it up, they just went through and said, okay, any motor over this much horsepower, we're going to track it, right?
Yeah.
Well, they were doing vibration analysis on bathroom exhaust fans for change rooms. It's a big fan. It's not a small
Hmm.
fan, but they were doing vibration analysis on those. And if one fails, it's a little unpleasant, but it's not the end of the world in this particular location. So
Hmm.
they were wasting money there, and that's easy to do. So you need a criticality process to help you understand which condition monitoring tools you're going to use where.
Hmm.
Uh, for any given piece of rotating equipment, there are lots and lots of different tools that you can use.
Hmm.
You could go out there and on a specific pump or device, you could have vibration analysis, tomography, ultrasound, uh, any number of things, right?
Hmm. Hmm.
And if it's got a sump, it would have lubricant analysis. So what you have to do is go, well, do I really need this many tools on this item? And the best way to help you determine that is to have a good, strong criticality process so that you know which equipment needs the most monitoring and which equipment doesn't need any.
Hmm. Hmm. I see. Great stuff. So, how do you overcome this challenge yourself? Because, of course, what you do
Training,
takes also a lot of convincing. So, training and repetition. Is that
training, repetition, communication, getting the right people in the room and getting them to understand it. Now, when you go to a site,
hmm.
the site manager doesn't have a lot of time to spend on training, so he's not going to be in a training session.
Yeah.
But if you can get 10 minutes with that guy and show
Hmm.
him what the benefit is, that usually helps.
Yeah, exactly. So, it's all about the benefits, I guess. You need to find
Right,
out people also in different positions would have different benefits that would appeal to
right.
them, I would guess. So,
Super. And if you're going to try to start a condition monitoring program, you've got to build a business case for doing that.
yeah.
Because it is a significant investment. It's not like it's free,
Yeah.
right? I mean, the payback's great, but there's a lot of upfront work that goes into creating a program if you don't already have one.
Yeah. And I guess you would help to do that on a company specific basis. That should be,
Right.
I assume that's part of the process. Yeah,
Not just company specific, but site specific.
of course. Yeah.
Right.
Great. Great. Okay. There are no further questions.
Ahmed
Maybe.
had a question about
Yeah.
how
Let's see.
about a fleet of on highway trucks? I
Hmm.
haven't dealt with fleet maintenance, so
Hmm.
I don't know how much is there. I know a lot of the larger trucking companies use lubricant analysis to help them manage their fleets.
Yeah. Yeah. That's right. Well, we're looking also at some applications for this with our ruler test, of course, to determine the additives that are left in the oil.
Right,
Potentially, and this also links up to what you were saying earlier, Bill, about convincing people. Potentially, there's a lot of benefit if you can do condition monitoring on loop oils and do more of a condition-based maintenance based on your findings. If you
right.
have enough trucks and enough oil circulating, then there will definitely be benefits. But it's a matter of, on the one side, how are you practically going to do that, and on the other side, it's not.
Right,
It's very far from the status quo at the moment. So you need to convince
right.
people to do it and to try it. But it's an
Right.
interesting. Sorry.
I think the newer engines don't contaminate the oil as badly as
Yeah.
older technology did. And
Yeah.
then it comes down to whether you've lost your lubrication capability or whether you've lost your additives
Yeah. Correct.
that prevent the corrosion and all that kind of stuff.
Yeah, that's true. But what we also have seen in the market is that newer technology can fail also more drastically than
Oh yeah,
the older stuff. If a
yeah,
turbocharger, the downsized engine with a turbocharger, if it has a little bit of a lapse in lubrication, the turbocharger will break.
it's done. Yeah,
It's done. Yeah. So it does make sense to be a bit proactive there. But how this will be implemented in the future. It's an interesting thing to follow, I think.
It won't be a matter when everything has electric motors instead of diesel.
Yes, but
I don't think I'll live long enough to see that, but hey.
that might be a while. Let's get the
Yeah.
electricity sorted first then.
Yep.
Yeah. Okay, great. Yeah, I don't see any further questions. Do you have anything to add, Bill? If not,
No, I just want to thank everybody for being here. I hope we were able to answer your questions. Look like Sonia has put a comment in. Thank you, Sonia. Appreciate it. And thank you guys for inviting me to speak. I enjoyed it.
thank you very much, Mr. Bill Keeter.
You're welcome. Bye-bye.
Bye bye. Thanks, everybody. Enjoy the rest of the LRVS. Take care.